During the 2019 COVID lockdown in Melbourne, when the world slowed, I began building the State-Saving Interpreter, or SSI, the logical next step after my List Prolog interpreter. What started as a list of features on a notepad became a compiler, a hand-built system that controlled its own data flow. A deeper dive into how logic itself could remember its state. I began by writing down every feature I wanted. Then I turned those features into input, output, and program specifications in order, and from there, into code. But SSI wasn't just another interpreter. Unlike the List Prolog interpreter, which relied on Prolog's built-in choice points to manage backtracking, SSI manually controlled everything: the data flow, the algorithm, the branching logic. It acted as a compiler written inside an interpreter, representing the algorithm as a data structure that could move between points, backtrack, or choose alternatives, all by hand. I ran test after test, 15 in total, and another broke each time I fixed one. Then came the most significant obstacle, the one I called the Queen bug. It was the main barrier between me and 100% correctness. The issue lay in a delicate region of code that handled backtracking conditions. The interpreter had to recognize when to backtrack and simultaneously identify the algorithm data structure's current choice point. Miss either step, and the entire logical fabric collapsed. I spent days tracing the code, printing variables, and trying small changes, seeing how they rippled across other tests and timings. It was a dance between pinpointing and emergent debugging, not just following the trace, but feeling how the algorithm behaved. Then, almost miraculously, I found it. A single overlooked condition, one alignment between the backtrack check and the choice point reference, and everything clicked. When I reran the tests, they all passed. The Queen bug had fallen. The experience showed me something profound: that debugging isn't just technical, it's philosophical. You're not only fixing code, you're understanding how reasoning itself breaks and heals. In hindsight, I would have applied my later spect algorithm method to structure the logic, perhaps eliminating Prolog's choice points and completing test 15 using overarching loops. Because in the end, an interpreter is like a loop, and every layer we compress towards C or assembly brings us closer to pure thought, expressed as computation. So that's the story of the Lucian Academy bug, the Queen bug, the moment when logic itself fought back, and I learned how to trace not only code but consciousness. Thanks for watching. Stay tuned for the next episode if you'd like to see how spect algorithm, or the manual neural net, grew from this project.